All right, guys. So for this lecture, we're going to take a little bit of a look at the stomach and kind of the contents of it, as well as just kind of some introductory stuff for the alimentary canal or the canal leading down to the rest of it. Um, so we'll start off here with kind of alimentary canal. There's a couple different layers that we need to talk about. So the first one is what's referred to as mucosa. So this is the innermost layer, so the very inner layer. And this is the layer of the alimentary canal in different areas that will absorb things for us. Because of that, it's a moist layer, meaning it has some mucus as well as some interstitial fluid as well on it. Has a small amount of connective tissue. This layer is mostly what's called the lamina propria. This is what actually connects the mucosa to the underlying layers. Most of this is going to just be simple surface epithelium because this is where most of our absorption is taking place, right? And then we also have a small layer of smooth muscle, which is going to help us with our peristalsis process, okay? But just below the mucosa is the submucosa, okay? This one is mostly connective tissue, and this is where all of our blood vessels and nerve endings as well as lymphatic vessels are as well. So you can see this is kind of the submucosa right here, right? Everything is in there. Anything absorbed by the mucosa goes directly into the submucosa and then is picked up by those blood vessels or lymphatic organs and then transferred throughout the body. Right. Next layer in line then is the muscularis externa. Right. This is smooth muscle. You can see it right through here. Okay. So the very kind of darker pink layer is the muscularis externa. And there's two different layers of tissue here. So there's an inner layer, which is circular. Okay. You can kind of see that right here on the diagram. And then there's an outer layer that is longitudinal. And those two muscles kind of work together to be able to kind of help us move or function for peristalsis. There's also what's referred to as the serosa, right? And this is the very outer layer of the alimentary canal. And this is what connects it to the visceral peritoneum, as well as it also has some cells in it that help us produce some fluid. Because think about this tube is kind of laid next to, especially in the abdominal cavity, next to another tube. It has to produce a little bit of serous fluid to kind of keep itself lubricated so that it doesn't rub next to another one. All right. This just shows you another picture of kind of what that looks like. You can see your different layers here. So you've got your submucosa. So you got your mucosa here, right? Here's the muscle layer that is associated with the mucosa. Submucosa is this whiter layer through here. You can see blood vessels and nerve endings, as well as some of the lymphatic glands. Here is the muscle layer. So you can see the different two layers. So here's the circular layer right here they're showing, and then this kind of dotted structure around the outside is the external layer of that. All right, and then finally you've got the very outside of that, which is then your serosa. Okay, there's kind of a curtain of stuff called the mesentery that kind of holds all of this together. It's mostly just kind of fat material. Three parts of the alimentary canal for the nerves. Okay, so each part has its own, which is kind of interesting because you can kind of tell based on the nerve impulses that we're getting, maybe of kind of where the problem is in the alimentary canal. So there is the submucosal nerve plexus. Right, this senses kind of stretch receptors as well as kind of issues with absorption. The myonetric nerve plexus then is kind of next, right? So it sits just outside of the submucosal, right? This is mostly muscle tissue. And the subserosus plexus just sits inside of the serosus layer. So if we've got some issues based on kind of maybe the serosus rubbing up against another layer, we can kind of detect that there. Stomach functions, all right? So for the most part, the stomach just kind of is for storage. And it's really for us to help kind of break down this food. Not a lot of absorption happens in the stomach. We're mostly looking at kind of breaking down this, specifically chemical breakdown. So this is where our hydrochloric acid or stomach acid is kind of dumped into. And what it's really trying to do is get this whole thing processed and turned into a kind of bolus called chyme. And deliver it to the small intestine, because really where most of our absorption takes place is in the small intestine. Okay. Stomach anatomy, it's mostly located over on the left side of our abdominal cavity, just below our liver, all right, and diaphragm. Food enters the stomach through a sphincter called the cardioesophageal sphincter. That's this one right here, right at the bottom of the esophagus, just above the stomach, sits right, pretty much right here by the diaphragm. Sometimes it's referred to as the cardiac or lower esophageal sphincter. Right, there really is no upper esophageal sphincter. All right, it's just kind of an opening. But the lower esophageal sphincter is right here. This one should keep things from coming up, but doesn't usually. Okay. Stomach anatomy a little bit more. So there's a couple different regions. So obviously there's a cardiac region. This is the portion that sits right pretty much next to the heart. So that would be this upper portion here. All right. There's the fundus. This is the upper rounded portion. All right. So when things come in, the stomach kind of makes this little bit of a jut upwards. That's the fundus. The body is just kind of the bulk of the stomach here. And then there's the pylorus. This is the area where it now starts to join to the small intestine. All right. At the bottom of the pylorus, there is what's referred to as the pyloric sphincter. And this is where food would enter the small intestine but could not make its way back into the stomach. Inside of the stomach, we've got a couple different layers. So we have the rugae. These are the inner little folds you can kind of see in here. Some people sometimes say it looks like the surface of the brain, which it does a little bit. And then there's the external regions. There's two of them. There's the lesser curvature, which is here on the medial side of the stomach, and the greater curvature, which is on the lateral side, facing towards the abdominal wall. So this lesser curvature faces towards the liver, actually. Okay. Couple different layers here. So the layers of what's referred to as the peritoneum, which actually is attached to the stomach. So this is the peritoneum is kind of this curtain of fat that kind of holds the stomach in place. There's the lesser omentum that actually connects the stomach to the liver. All right. So there will be a little bit of an attachment point here. There's the greater omentum, which attaches the rest of it to the abdominal or the body wall. So this is the greater omentum, kind of looks like a big curtain of fat. When we dissect the cats, this is kind of what it looks like. Again, you've got liver up here. This is the stomach, kind of looks like this deflated balloon just below it. And then this is the greater omentum. It's just this kind of curtain of fat that sits over the top, kind of holds all the abdominal organs together. It's really there to help kind of with insulation as well as kind of cushioning and kind of help protect those abdominal organs. There's no bone structures over the top of this, so it needs a little bit more protection, and that's one of the reasons why that's there. For the most part, cells that are inside of the stomach, it's simple columnar epithelial. We've got these kind of mucus neck cells. They produce a huge amount of sticky alkaline mucus to kind of help buffer those cells against the harshness of the gastric juices. All right, we have gastric glands that secrete hydrochloric acid or our stomach acid. Chief cells, which are producing some enzymes, protein digesting enzymes called pepsinogens. We have parietal cells, which are producing specifically the hydrochloric acid. And then we have endocrine cells, which are producing gastrin. All right. So we really only have a couple different things kind of going on in there. I know there's a lot of cells there, but main ones you need to remember are the parietal cells. Those are the ones that produce the hydrochloric acid. And then the kind of chief cells and endocrine cells producing both of these kind of enzymes here. Okay. Those gastric juices are actually regulated by neural and hormonal factors. So when you look at food, the brain actually sends a message to the stomach to start preparing some of these gastric juices for food to show up. Okay. The presence of food falling, the presence of food or the falling of pH can actually cause the release of gastrin. All right. So when food makes it into the stomach, it interacts with hydrochloric acid as well as the gastric juices to change the pH. So if the pH gets lowered, we start to see the release of these enzymes. And then the gastrin really causes the stomach glands to start to produce more of that hydrochloric acid as well as some of these enzymes to start the process of breaking down that food. All right. The hydrochloric acid itself really makes the stomach contents very acidic, and that's the environment really we need to kind of break down some of those things into the processes. Okay, we'll take a real quick look here at this video for you guys. This is hydrochloric acid itself. I won't show the whole thing, but we're looking at kind of a hamburger here. I'll kind of skip through. So they're going to pour a little bit of hydrochloric acid directly into this vessel. They're going to take the hamburger out. All right. They're wearing special chemical gloves here. Those aren't actually just nitro gloves or okay. You can start to see a little bit of some breaking down happening here. So you can see the discoloration of the carbohydrates on the outside. So the stomach acid is really kind of interacting with that. Now you can see we're getting a little bit of kind of some smoking, right? So that's really starting to break down this tissue. All right, I'm going to skip ahead just a little bit here for you. So you can see we're about 2 minutes in and we've seen a little bit more of this process. All right, so food really does spend quite a bit of time in the stomach. It's not like we just dump it in there and it immediately dissolves. I mean, it will dissolve it, but it takes some time. All right, so you can see the bun has really started to fall apart here. All right, we get to about 3 minutes in. It's really started. They're kind of so they're trying to simulate a little bit of kind of the mixing of the stomach here with a spoon. All right, and then we get to the very end here. We can see it's pretty well mixed up. Okay. All right. All right. So, kind of talking a little bit about those structures of the mucosa. So, there's these little things called gastric pits. This is where a lot of those things are being produced, and those are the ones that are producing both the gastric juices as well as the hydrochloric acid within these little pits. So, these are your goblet cells that we talked about during the tissue chapter that are protecting these cells next to them. Right. And then just looking at the environment of the stomach here, so the environment actually activates these pepsinogens, which are proteins in pepsin, which help to digest specifically proteins within the food that we take in. Remember, most of our carbohydrates started digestion in the mouth, but in here, the stomach really starts to digest those proteins, and really, it's providing an environment that should kill off pretty much anything if it were hanging onto our food when it got in there most of the time. Right. So digestion and absorption in the stomach. We have protein digestion. So again, just real quickly, the pepsinogen and the renin. Pepsinogen is specifically digesting enzymes in most of our food. Renin is specifically just milk digestion. And for the most part, the only thing that can actually be absorbed within the stomach is both alcohol and aspirin. Everything else gets absorbed in the small intestine or in the oral cavity. So we don't really see a whole lot of absorption anywhere else. Okay. Propulsion of food. So obviously the food's being mixed around here in the muscular layer of the stomach. And we're really trying to get it produced into this kind of formation of what's called chyme. So the peristalsis affected the stomach. So sometimes you'll hear that kind of gurgling of your stomach. What it's actually doing is processing that food. All right. The pyloric sphincter or the pylorus will actually help to meter out that in small amounts. So we don't want a ton of it dumped into the small intestine at one time. We only want about 30 milliliters at a time. All right. And it will take about 4 to 6 hours for the entire stomach to empty. Okay. I'm going to wait and kind of show this one. You know what? I'll go ahead and show it. That's fine.
When you swallow food, it travels through a tube called the esophagus. The esophagus leads into the stomach through a hole in a sheath muscle called the diaphragm. There's a round muscle at the bottom of the esophagus that works like a valve. The muscle relaxes when you swallow, allowing food to pass into the stomach. Certain cells in your stomach, called proton pumps, release acid to help digest the food. The lining of your stomach protects it from the acid. The esophagus has a different type of lining, which looks like it's made of smooth tiles. The valve is designed to close tightly after you swallow, so nothing comes back into the esophagus. Your diaphragm is also meant to pinch securely around the esophagus, closing off the opening to your stomach. It's normal for a small amount of acid to occasionally splash into the esophagus. This is called reflux. That word means flowing back. A small amount of reflux doesn't usually cause any harm. But if acid splashes up into the esophagus over and over again for years, the esophagus can be damaged. There are several reasons this might happen. It's not uncommon for the valve to become weaker, so it doesn't close tightly. That allows acid and partially digested food to come up into the esophagus. Sometimes the diaphragm weakens around the esophagus, allowing the hole to become larger. This hole is called the hiatus. When it becomes larger, part of the stomach may bulge through it. This is called a hiatal hernia. The hernia may cause the esophagus and the valve to move up. In that case, the diaphragm is no longer reinforcing the valve. That makes it more likely that acid will get into the esophagus. When acid and food splash up into the esophagus repeatedly, it's called gastroesophageal reflux disease, or GERD. Gastro for the stomach, or gastric system, esophageal for the esophagus. Mayo Clinic's Division of Gastroenterology and Hepatology is recognized as #1.
All right, I'll go ahead and stop it there, but that shows you a pretty good idea of kind of what that GERD process looks like, okay? All right, so we'll take a little bit of a look at all right, so the last little bit here then is talking a little bit about kind of that kind of what results from those sometimes that GERD situation or an overproduction of stomach acid. So you can get what's called a peptic ulcer. So these are small little openings or lesions within the mucosa because of the overproduction of digestive enzymes as well as stomach acid. So they create these little openings or holes, right? So when people talk about having an ulcer or having kind of openings in their stomach or having kind of gastric reflux, we're looking at stomach acid making its way back up into the esophagus. And in these cases, we have gastric ulcers. These usually heal themselves pretty quickly. The only issue is as we age, we tend to not heal them as well. So it's not unheard of for somebody to actually die of a gastric ulcer at a fairly decent age, usually well up into their 90s, almost into 100 years old, as long as their body can't heal those processes. So we can get ulcers within the stomach. And then if there's enough of that stomach acid leaking out into the small intestine, we can get ulcers into the very upper portion of the small intestine called the duodenal. And that really can kind of be very painful, obviously. It can then can cause some other issues because if it eats its way through the stomach, now we've got stomach contents making its way into the abdominal cavity or small intestine contents making its way into the abdominal cavity. Okay. All right. We're going to go ahead and stop there. That finishes the notes over here of the stomach.